Hi, welcome to this video in the MRDCL Understanding Concept series. In this video we're going to look at the subject of target weighting and how you can handle that efficiently in MRDCL. You'll find the files that are used in this video in the folder tab TAB 102. So what we've got here is a simple script actually, but the purpose of it is to weight to a matrix of age within gender. So first of all, let's just make sure we understand what target weighting is. Target weighting is where you have some populations or some targets that you want to weight your sample to. In this particular case, I want to weight to a matrix of age groups by gender so that my data represents those targets. Now there's two types of targets that you will commonly encounter. One is where you have figures that you actually want to reach. So you might, for example, have surveyed 20 people who are male under 25, but you wanted a target of 35 people. So you would weight those 25 people by 35 over 25 to achieve the target of 35. There are other occasions where you want to weight to a percentage. So you want, for example, the males who are under 25 to represent maybe 12% of your sample. So there the target would be a percentage. And of course you'd need to work out, or the software you'd want the software to work out what percentage of respondents fall into the category of male 16 to 25 or under 25. So that you could say if it was 10%, and you wanted 12.5%, so that you could weight the 10% by 12.5 divided by 10 and apply a weight of 1.25. All right, so the first thing we're going to look at is weighting to actual numbers. We'll do another example in a minute. We'll weight to a percentage. The principles are the same. There's just an extra trick that you need to know to achieve that. So what we've got here is we've got a script that picks up some data. It picks up gender, it picks up age, and it has one other variable in there. And what we need to do to actually calculate our weight factors that we want to apply is to set up some tables that do that arithmetic for us. So what I'm going to do, and if we go down to the table stage here, you'll see that I've got three tables being prepared, and I'll go through those in a little bit more detail in a second. I've got a table which I'm calling actual. It doesn't have to be called actual, it's just my name for it. A table called actual, which gives me a table of the number of people for each cell of age by gender. So I can get a table showing me the figures that represent each of those cells. And I've got 3 age groups and 2 genders, so the table will have 6 cells. Then I'm going to set up a table which is going to have my targets in it so that I know what figures I'm going to be weighting up to. And then I'm going to use MRDCL to calculate the factors by dividing the targets by the actuals. And then in the final step, I'm going to pick up those figures from the table factor and apply them to my data. So they're the sort of steps I'm going to go through to achieve the target weighting that I want. All right, so the variables at the beginning were very straightforward. I just defined gender as 2 codes and age as 3 codes from my data. So let's look at the first table. The first table is just like a standard simple crosstab, and actual will give me the figures of age by gender. So nothing at all unusual about that. You can see I've pulled in some format options here just for tidiness. So I've actually suppressed the total row and the total column with MPTR and MPTC, and I've suppressed percentages because I'm actually, in this particular example, only weighting to target figures. I'm not weighting to percentages. We'll cover that when we get to the next script. So that's my first table, so that's pretty straightforward. Now the second table, I'm going to put my targets into. Now the way we do this is we set up an empty table so that using manip, I can put the figures into the target table so that it's ready to go and divide one by the or target by the actual to give me the factors. So here I've got a table called target. It's exactly the same shape as it were as the actual table. It's got age down the left hand side, gender across the top. and it's got some format options. It's telling me to not increment that table, so I want this to remain at this stage as an empty table. Again, I don't want the total row, I don't want the total column. I'm suppressing the percentages, and I thought it would be useful to have the figures to one decimal place so I can see what I'm working with. The next thing I'm going to do now is set up the same thing again, an empty table, exactly the same as the target table for the factors. So that's my table stage, and if I were to run that without a manip stage, I would just get two empty tables, and in actual I would get the figures that actually represent my real data of age by gender. Now I can go into the manip stage and I can define the targets that I want. So here's a piece of manip code, and what this is saying, for my table target, $1-, now I could put 3 in here because I know I've actually got 3 rows in it, but I prefer to put $, because $ just means the last row. So for rows 1 to $, to the last row, and for column 1 to $, so going across column 1 to $, I want to put in the figures that are going to be my targets. Now MRDCL expects you to work across the page, as it were. So what it's saying here is I'm putting 20 for row 1, column 1. In other words, for the first age group and the first gender, my target is 20. The second figure will be the first row, but the second column. So I'm setting a target of 30 for the first age group and the second gender. And then that's the end of the gender column, so now it's going to go on to the next line effectively. So I'm setting a target of 40 for the second age group and the first gender, and so on till I get to the final third age and the second gender. So there's my targets. A slightly different syntax to what you might be used to. There's a bracket before, a bracket after, and a comma on the end to tell MRDCL that's the list of figures that I'm going to be putting in. Now I'm going to calculate the factors. So the factors, now I want to tell it I only want to do this on rows 1 to $, column 1 to $, and I'm going to do this by saying I want the factors to be the targets in row 1 to $, column 1 to $, divided by the actuals that we calculated in the table stage, or we set up in the table stage, row 1 to $, column 1 to $. So that calculation in factor now is going to, if you like, hold a table with 6 cells in it. So I think it's a good time to have a look at this and see what we've got. So let's save it, let's run it, and let's look at what we've got. So here's my sample of 7 respondents. 2 go into this category, 1 into this category, and 1 into each of the others. And there's my target. So here's my target of 20 for the target table, 30 here, 40 here, 50, 60, 70, the figures that I put in the manipulation stage. So the factors that I would expect to apply for this cell here, the under 35 males, well, I've got 2 of them, and the target is 20, so I'll expect a factor of 10, whereas all the others I've got 1, so the factors actually will be the same as the targets, 30, 40, 50, 60, 70 for the other cells. If we scroll down, you can see that's exactly what MRDCL has calculated. It's calculated a factor of 10 for that cell, but the others, because there's only 1 in the sample, are 30, 40, 50, 60, 70. So that appears to be working so far, and that's good. So let's move on and see now how we implement that weighting. Now you'll see that what we've done here is we've opened a table stage, closed it, opened a manip stage and closed it. There's no problem now opening another table stage and starting to do whatever I want to do in another table stage. It will work off the manipulated figures effectively. And indeed, I could have my tables in a separate STP file, just as you can have split setups that have a data stage and a table stage in separate setups, so that you use IDF equals in the control stage to pull that through. There's nothing to stop you having an ITF equals to pull in, for example, the weighting. So this piece of code here where I'm doing my main work and my main tables, I could pull that into another table stage that works as an ITF off the run that we're working on now. However, I've got this all in one folder, or in one file. So here I'm now defining a variable called weight matrix. It could have any name again, which is age dot by dot gender. So what it's doing now is actually exploding that matrix of age and gender out into one variable. That's the same as saying I want a variable of 6 bits, where the first one is age of 1, gender is 1, age of 1, gender 2, age of 2, gender 1, age of 2, gender 2, age of 3, gender 1, and age of 3, gender 2. So that's the same as typing that in. That dot by dot transformation there effectively is producing 6 bits that are going to match, if you like, those 6 figures that we put in there. Now I can pick up my weight, and I can use another transformation that's a very powerful tool in MRDCL. I'm now saying that my weight comes from the variable weight, picking up that relevant bit or value from the table factor. So weight matrix has 6 items in it. The table factor has 6 items in it, or figures in it. So the first bit in weight matrix, which is the first age and the first gender, is going to pick up the first calculated figure in those tables, which you may remember was 2 respondents, target 20, and producing a factor of 10. And so on through the other 6 bits in the variable through to age 3 and gender 2. Now that my variable weight contains the weight, I just need to apply it, assuming I want to apply it, and I can select WR $weight, and if I now do a table, table 1 age by gender, I will get a weighted table. If we want an unweighted table, I could say select WR1 to turn weighting off, and I could say table 2 is age by gender, and this will be an unweighted table. I'm going to put in a title of unweighted in there just so we can see the difference. Let's run this again. Let's just check everything's working. We've seen the tables that calculate the actual, target and factor. We can now move on and look at our table. Well, there's the targets that we set, and you can see now when the table's weighted, table 1, we get the 20, 30, 40, 50, 60, 70 people that we set as the targets for our 7 respondents. And we also getting an unweighted row here telling us that actually our 7 respondents broke down into 4 males and 3 females. Table 2 is the unweighted table, so that just is the data as it is, 7, 4, 3, 3, 2, 1, and that's of course the same as the actual table with just a total row and column around it. So it looks as though my weighting is working perfectly well in this occasion, I'm glad to say. We can do a few more things. I want to mention a few more things in here. One thing that you might want to do in here is to not actually print these tables. Having checked that they look sensible, it's quite a common thing to say not print table for the actual target and factor. So that's a way of just suppressing those tables. They'll still go ahead and do everything they've got to do, but we won't actually get them in our output because maybe we don't want the client to see those calculations, or we want to just not have them at the front of the volume of tables. A couple of other things to think about. This example here works out age by gender. It doesn't do anything when perhaps you've got 3 dimensions in there. So how do we approach that? Well, let's say you wanted to do age within region within gender, for example. All you'd have to do there would be, you'd have to get it back down to a 2-dimensional table to be able to do it, because tables are 2-dimensional. So rather than having age here, you might have a variable called age underscore region, which has already got age here, region in here somewhere, and already has done a dot by dot to merge age within region. So then you can make your table age within region by gender, and everything will work absolutely fine. Obviously you need to think about the figures that you're pulling in, but it will be age within gender, and you'll get a bit bigger matrix. It is possible also to do tests on cells. It's a good idea actually to keep the factor table until you're sure it looks right, because things can go awry if you've got nobody in a cell within a table. So say, for example, you did do age within region within gender, and you happen not to pick any respondents up who were maybe 16 to 34 males in the north. That would cause a problem, because you're just effectively going to lose those people from your targets, and you might find that your tables under add to what you might expect, or the weighted base won't be as big as you'd have thought, because you can't weight 0 people up to a value. That would obviously not work, and so they effectively get lost from the population that you might be expecting. So that's one scenario that you want to be able to deal with if you want to 3-dimensional. Of course, that can go to 4 dimensions. You could do age within gender, within region, within class, and so on by another variable, and that would also work. Again, the more you split this down, the more cells you're going to have and the more chance you've got of empty cells. The other thing that you might want to do is have 2 sets of weighting applying. So let's say you wanted to independently weight age and gender within region. There'd be nothing to stop you having a set of matrices here that are filtered on region 1 or region 2 and region 3. They would need different table numbers, so you might call these Act 1, TAR 1, FAC 1, Act 2, TAR 2, FAC 2. No problem with that. You would obviously double the number of divisions here that you would do and the number of settings of targets. So you'll be setting TAR 1 to a set of figures for the first region, TAR 2 to a set of figures for the second region. But basically you'll just be replicating this code. And same when you pick up the variables at the end here, you would say if weight matrix was region 1, pick up from FAC 1, if it was region 2, pick up from FAC 2, and so on. So that's all quite possible to be able to be done, but you'll just multiply the number of tables up. That's all by the number of things that you wanted to weight independently. Again, you could do it by dot methodology as well. So having looked at how we handle target weighting when we have actual numbers that we want to weight to, let's now turn to looking at how we weight to percentage targets, because actually that's probably slightly more common. The principles are going to be the same, but there are some extra things that you have to do. So let's have a look and see what's different about it. Everything looks pretty much the same until we get down to here, and then you'll see there's an extra table in here called sample. And we have got MPTB running this time, so it's going to suppress these tables. And what sample gives me is a table which says star comma. It's just going to give me a table with the sample size in it. So in this case, I've got 7 respondents, so it's going to store that as 7. The next difference you're going to note is that the targets now are percentages and not targets in the sense of numbers. So we've now got 10%, 12.5%, 12.5%, and so on. So they're my targets, and they're going to add to 100%, I hope. So let's turn now to looking at how we handle target weighting when it's percentages. And everything looks pretty much the same down here until we get some way into our tables, and you'll see that there's an extra table here called table sample. F equals MPTB means we're not actually going to print it, but the definition is just star comma, which looks rather strange, I must admit. That star comma, what that's going to give us is a 1-cell table with just the total sample. In this case, you recall we have 7 respondents, so it's going to just give me the figure 7. Everything looks the same down here, except you might note that my targets now will add to 100% or 100 rather than a weighted base figure that we just desired. So they now add to 100. Everything looks pretty similar here. We're calculating the factors by saying that the factors are target divided by actual, just as before. But this time what we want to do is rescale it back to our sample size, which is 7, divided by the 100%, that's the sum of the targets. So the way we do that is to multiply it by a variable called totsump, which will hold the value 7. We'll come back to that in a second, and divide it by 100, which is the target of the percentages, which is of course 100% in this case. The way we get that variable totsump there to be 7 is to pick up that table called sample and pick up row 0, column 0. And that's a piece of syntax that's perfectly allowable, where you can define a variable from a cell in a table. It's not something that's done very often, but it's something that you can do. You can pick up a variable based on the cell of a table. So I'm saying that totsump equals sample. It comes from sample, table sample, row 0, column 0. And now everything is pretty much as usual. It's just going to go through and apply those factors. And it's also here got some code that's going to tell me if any of the cells are empty. So there's a little loop here saying, well, if the value is 0 in my actual table, I actually want to stop the run. There's a stop command here and not continue. So it's checking every cell of my matrix to make sure I've got somebody in there. But then after that, it's applying the weights in exactly the same manner as before. So that's just an extra little twist. If you want to weight to percentages, you need a table called sample, and you need to pick up the sample size into a variable. And here you will multiply the factor by the sample size divided by 100, so it comes back to the weighted base you'd expect. Let's run that and just check it works as I think. I run it, and we look at our tables now, and if we look at them, you'll see they're weighting now to the percentages we set up, which were 10.0, 12.5, 12.5, 40, 15 and 10. So it looks as though everything is working fine there. Just as a reminder, you might want to look at those figures again. There they are, 10, 12.5, 12.5, 40, 15 and 10. So again, it looks like our weighting is working and we're getting the right percentages that we wanted, rather than the whole numbers that we did in the first example. The percentages here are matching exactly what we would hope for. Well, that completes this video. Thank you for joining us. There's a separate video on the subject of rim weighting which you might want to watch, because that is, again, a slightly different technique, although it uses some of the principles that you've learned in the target weighting video. Thank you.